Hello and welcome. Tonight we're going to settle in with a story about warmth. Not only the kind you feel from a blanket or a fire, but the deeper warmth that hums beneath everything. The science of heat and energy that quietly guides the world. Don't worry, I'll do my best not to make this too fascinating. This is, after all, bedtime, not a classroom. Think of it as a journey through the science of comfort, told slowly enough that you can drift off whenever you like. So, before we begin, take a moment to like the video and subscribe. But only if you genuinely enjoy these sleepy science wanderings. And if you're still awake by the end, I'd love to know where you're listening from and what time it is. It's always wonderful to picture these stories glowing quietly in different corners of the world. Now, dim the lights, pull your blanket up a little higher, let the air around you settle. Feel that soft layer of warmth gathering close to your body. That, right there, is thermodynamics in action. And with that thought, let's ease into the story together. Imagine a hearth. A small fire burns in the grate, flames licking upward, smoke curling lazily into the chimney. Around it, the air is golden and soft. You sit nearby, hands stretched out, feeling the glow sink into your skin. A kettle hums gently on the iron plate, tiny bubbles forming and rising. The room is calm, the world outside cold, but here you are warm. This is where thermodynamics begins, not with complicated equations, but with the ordinary miracle of heat. People felt its presence long before they had words for it. They noticed the relief of a fire on a winter night, the way a cooked meal soothed hunger more deeply than raw roots ever could, the comfort of lying beside another body for warmth. Long before scientists explained energy, heat was lived experience. You drift now into an older time when the hearth was the center of the home. Families gathered close in evenings, stories whispered in the glow, shadows dancing on walls. The fire cooked, the fire lit, the fire warmed. It was the heart of the house, and in a way, the first laboratory of thermodynamics. Even today, you can feel the ancient comfort of heat. Think of holding a mug of tea or cocoa. At first, the cup is almost too hot to touch. Slowly, it cools, the warmth leaving the liquid and slipping into your hands, into the air. You take a sip, warmth traveling inside you, spreading from the core outward. You feel it not just on your tongue, but deep in your chest. That flow from hot to cooler, from higher energy to lower, is the simplest whisper of thermodynamics. Heat always moves, always shares, always seeks balance. Scientists still wonder how best to describe heat. For centuries, it was imagined as a fluid called caloric, a kind of invisible substance that could be poured from hot things into cold. Only later did we learn that heat is not a thing at all, but a kind of motion. Atoms and molecules jostling, vibrating, colliding. The hotter something is, the more its particles dance. The colder, the slower they sway. But you don't need to picture atoms tonight. It's enough to notice the gentleness of warmth as it reaches you. The way a blanket slowly collects the heat of your body, keeping it near. The way a room feels different the moment you step inside from the cold, a kind of invisible embrace. Every time you breathe out, a faint cloud of warmth leaves you, slipping into the room. Every time you breathe in, the air answers. You are part of this quiet exchange, your body balancing with the world around it. Think of lying beneath a quilt. Beneath the fabric, the air hardly moves. The warmth of your body fills it, trapped, held close, while the cold outside cannot intrude. That's insulation thermodynamics used for comfort. Or picture sitting by a campfire at night, flames crackling, sparks lifting into the dark. On one side, your skin warms, almost too hot. On the other, the air is cool, the night pressing in. Turn slowly, and the warmth moves with you until all of you is balanced. This is the heart of the subject. The way heat flows, the way energy moves, the way everything seeks balance. It's not a harsh science. It's not only about steam engines and equations. It's about the simple, reassuring truth that warmth finds its way, that cold softens, that balance comes always. You drift now through scenes of warmth. Ancient hearths glowing in caves, Roman baths steaming in marble halls. A child asleep beneath a woolen blanket, tea cooling slowly on a table, sunlight spilling across a window pane. All of these are thermodynamics, the quiet rules of heat moving, balancing, sharing. And there is comfort in knowing that the laws of warmth are steady. That tomorrow, when the sun rises, its rays will bring warmth again. That a cup of tea will cool, a fire will fade, a body will seek balance with the air. Predictable, reliable, eternal. Scientists call this the zeroth law of thermodynamics, the law of equilibrium. But for tonight, you can call it simply the law of comfort. Warmth always shares. Things left together always find balance. You feel it in your skin. You feel it in your breath. You feel it in the hearth, in the blanket, in the night itself. So rest now in this first thought. Warmth is not just fire, not just heat, not just energy. It is balance, sharing, the universe leaning toward comfort. And as the hearth glows softly, and the kettle hums, and the night holds steady, you are part of that law too. The hearthlight fades, its glow settling into memory, and now you drift closer to the question that hums beneath it. What is heat, really? You felt it on your skin in a sip of tea, in the way the sun warms your face on a quiet afternoon. But the truth of heat is stranger, gentler, and more beautiful than it first appears. Heat is not a substance, not a liquid flowing invisibly between objects, though for centuries many thought it must be. Heat is motion, not the motion of your hands or your feet, but the hidden motion of the tiniest pieces of matter, atoms and molecules, jostling and dancing with one another. You drift down now into a simple mug of cocoa. To your eyes it looks still, surface calm, only a faint curl of steam rising. But if you could shrink down far enough, you'd see a riot of motion. Molecules vibrating, bumping, colliding, trading energy. Each tiny jolt adds to the sensation we know as warmth. The hotter something is, the faster those particles move. The cooler, the slower. Absolute zero, the coldest temperature possible, would be perfect stillness, no vibration, no movement at all. A limit we cannot reach, but which hangs like a poetic horizon. Scientists once pictured heat as caloric, an invisible fluid that poured from hot objects into cold ones, like water from one cup to another. It explained why touching a hot stone makes your hand warmer and the stone cooler. Something must have been transferred, they thought. It was a neat theory, and it lasted for generations. But the deeper truth revealed itself with time. Nothing flows in that way. Instead, the warmth you feel is the exchange of energy as molecules collide. Your cooler hand slows down the faster-moving molecules in the stone, while its heat speeds up the molecules in your skin. Energy isn't lost. It's simply shared. You can picture it like a dance floor. If one dancer is rushing wildly while another sways slowly, when they collide, they compromise. The fast dancer slows, the slow dancer speeds. After enough collisions, the whole floor begins to move in rhythm. That's what happens when heat is exchanged, balance emerging from countless tiny encounters. You drift now into different examples. A breeze across your face, molecules of air striking your skin, carrying energy away, leaving you cooler. Ice melting in water, the faster molecules of liquid colliding with slower ones in ice, sharing their energy until both meet in balance. Even the warmth of the sun, photons traveling across space, stirring atoms in your skin, setting them into motion. Heat, then, is not a thing. It is activity. It is vibration. It is the ceaseless, invisible shuffle of matter. Scientists still wonder how best to describe this to students. Do you picture balls colliding, or waves rippling, or tiny oscillations of springs? None of the images is complete, yet each gives a glimpse. The important part is the rhythm. Hot to cold, fast to slow, everything tending toward equilibrium. And perhaps that's the lesson worth carrying tonight. Heat is not chaotic, not random in the sense of purposeless. It is purposeful sharing. It is energy moving until balance is reached. There's comfort in that, isn't there? to know that the warmth in your blanket is just your body's molecules sharing motion with the air, slowed by fabric held close. That the cooling of your tea is not loss, but gift, warmth given to the air around it. That every flicker of comfort is the world equalizing, gently, patiently. So let yourself feel that truth now. The room has its temperature, your body has its own, and quietly, invisibly, they are meeting, adjusting, sharing. Heat is not a substance to hoard or lose. It is motion, balance, relationship. It is the universe reminding you softly that nothing is ever alone. Every atom dances with its neighbors. Every bit of warmth finds its way outward. Every coolness welcomes what drifts in. And as you rest, you are part of that dance too. The picture of dancing molecules fades gently, and now you drift into the first quiet law of thermodynamics, though curiously, it is called the zeroth law. It received its name later, after the other laws had already been written down, but it belongs at the very beginning. Why? Because it describes the most fundamental truth of heat. Warmth is shared. Imagine placing your hand around a mug of tea. At first, the cup is hotter than your skin. The molecules in the ceramic are jostling more vigorously than the ones in your hand. Slowly, quietly, they meet. Energy drifts from the faster particles in the cup to the slower particles in your skin. Your hand warms, the cup cools, until both meet somewhere in between. That meeting point is what we call temperature equilibrium. The zeroth law says, if object A is in thermal equilibrium with object B, and B is in equilibrium with object C, then A and C are also in equilibrium with each other. In simpler, cozier words, if they all share warmth with the same middle friend, then they all end up the same temperature together. It sounds so obvious, it hardly seems worth calling a law. And yet, without it, our entire concept of temperature would crumble. Thermometers, after all, rely on this very principle. Place a mercury thermometer in soup. The mercury shares energy until it matches the soup's warmth. Place the same thermometer under your tongue and it shares energy until it matches you. By comparing both, you trust that equilibrium tells the truth. You drift now through different images of shared warmth. Two people under one blanket, their body heat blending until the air beneath feels the same. A bowl of soup steaming on the table, its heat leaking slowly into the surrounding kitchen until the whole room feels a touch warmer. A stone warmed in the sun, its surface giving heat back into the night air once the sun has set. Scientists still wonder at how to phrase the zeroth law, so it feels less like common sense and more like revelation. But perhaps its beauty lies in its simplicity. The universe is built to balance. Left alone, Things will always share until they match. It is the reason you cool down when you step into cold air. It is the reason ice melts in your glass. It is the reason we can measure warmth at all. Without the zeroth law, temperature would be just a feeling. With it, temperature becomes something real, something measurable, something universal. And maybe it's also a quiet metaphor for human life. Sit with someone long enough, and you begin to share warmth, not just body heat, but comfort, calm, even silence. Just as two objects left together drift toward balance, so do people when they spend time side by side. So let yourself rest in this thought. The zeroth law is the law of sharing. No matter how hot or cold something begins, when they touch, they seek balance. The universe itself leans toward fairness, toward equilibrium, toward peace. You can feel it now, your body gently adjusting to the air, your warmth softening into the blanket softening into you. Nothing is rushed, nothing forced, just sharing until balance comes. That is the zeroth law of thermodynamics, and it is not just theory. It is the hearth, the tea, the blanket, the night. It is comfort made into law. The blanket of shared warmth settles quietly. And now you drift into the next great principle of thermodynamics, the one that tells us not about balance, but about continuity. The first law. You may have heard it phrased as, energy cannot be created or destroyed, only transformed. It sounds abstract at first, but it is really the gentlest of reassurances. Nothing is ever truly lost. Picture a candle burning on a table. Wax melts, the flame flickers, the air grows warmer, light spills across the walls. The candle seems to vanish, shrinking lower and lower, until only a stub remains. But the first law reminds us, the wax was not destroyed. Its energy became heat, became light, became motion in the air. What looked like disappearance was simply change. You drift now into a kitchen. Water in a pot begins to boil, bubbles tumbling upward in a quiet rhythm. The fire beneath transfers energy into the water, and molecules begin to jostle faster and faster until they escape as steam. The energy didn't vanish. It moved from flame to water to vapor. The first law is about this endless accounting. The universe keeps careful books, never letting energy slip away. The form may change, but the sum remains. Scientists still wonder at how comforting this principle feels, even beyond physics. In stars, in engines, in bodies, energy flows, transforms, shifts, but is never gone. The heat of the sun becomes the growth of plants, which becomes food, which becomes your motion and thought. Later, that energy drifts outward again as warmth, as breath, as the faint heat you leave behind in the room. Nothing wasted, nothing missing. Even you, at rest now, are part of this cycle. The food you ate became chemical energy in your cells. That energy keeps your heart beating, your lungs moving, your thoughts wandering through this story. Later, as you sleep, your body radiates warmth into the night air. Quiet transformations, all within the first law. You drift outward into space now, past the glowing earth, toward the sun. In its core, hydrogen fuses into helium, releasing radiant energy. That light travels across space, strikes Earth, warms oceans, feeds forests, fills your room with daylight. Energy passing hand to hand, never lost, only moved. Think of a swing in a playground. Push it and it rises, trading kinetic energy for potential, slowing at the top. Then it falls back, potential turning into kinetic, speeding once more. Back and forth, the total energy constant, the forms shifting like a pendulum's lullaby. And though real life has friction, losses, and leaks, even those are not destruction. They are simply transfers into the air, into heat, into sound. The swing's squeak is not wasted. It is energy released in another form. The first law tells us the universe is frugal. It spends nothing it does not already have. It loses nothing that cannot be found elsewhere. There's comfort in that, isn't there? To know that beneath all change, there is constancy. That nothing vanishes into nothing. That what warms, cools, flickers, and fades is still somewhere in some form, continuing the great story of energy. So as you rest, let the thought settle. Your warmth is part of the first law. Your breath, your stillness, your dreams, all threads in the endless weave of energy, moving but never gone. The candle flickers, the water boils, the sun burns, and energy, steady as a heartbeat, remains. The candle's glow fades into the quiet, and now you drift into one of the most practical gifts of thermodynamics. The way heat does work. Not work in the sense of chores or burdens, but work as physics defines it: motion, lifting, turning, carrying. The kind of work that gently transforms warmth into movement. Imagine a kettle on the stove. Water inside begins to tremble, then bubble, then push upward as steam. That steam is more than vapor. It carries energy, pressure, the ability to push against lids, wheels, or pistons. The kettle whistles, a tiny engine at work. Now drift back a few centuries, into the early Industrial Revolution. Picture a great iron engine, its pistons pumping, its wheels turning. Coal burns in the firebox, releasing heat. That heat boils water, the steam pushes pistons, and the pistons drive wheels. Out of simple heat, motion is born. This was the age when thermodynamics began to leave hearths and kitchens and step into factories and railroads. Heat was no longer only comfort, it became power. Scientists like James Watt studied how to improve these steam engines, making them more efficient, more reliable. From their observations came some of the earliest formulations of thermodynamics itself. Every stroke of a piston, every puff of steam whispered lessons about energy, efficiency, and loss. You drift closer to one of these engines now, not as noise or soot, but as rhythm. A piston slides forward, backward, like a slow heartbeat. With each stroke, wheels turn, trains move, ships glide, pumps draw water from mines. Heat, harnessed gently, remade the world. And yet, even in these roaring machines, the same simple laws apply. The first law, energy conserved, merely transformed. Coal's chemical bonds turn into heat, heat into steam, steam into motion. Nothing lost, everything changed. The second law, too, hums here. No engine is perfect. Some heat slips away, radiating into the air, lost as waste but not destroyed. Entropy increases, a quiet cost of every cycle. But for the people of that time, these engines were miracles. Heat became movement, fire became travel, warmth became work, and you feel the echoes still. Every time you ride a train, start a car, or even boil a kettle. Thermodynamics hums quietly in each. Scientists still wonder at the beauty of this transformation. It is not brute force, not magic, but balance. A dance of molecules becoming pressure, pressure becoming motion, motion becoming progress. And in your own life, you are an engine too. The food you eat becomes chemical energy, which your muscles turn into motion. Even as you lie resting now, your heart pumps, your lungs expand, your cells work tirelessly, all powered by energy, transformed gently from warmth into work. So rest in this thought. Every flicker of motion around you is heat at work. The kettle, the piston, the breath. Engines large and small, steady and gentle, humming with the same laws. The world itself is an engine quietly turning heat into the work of tides, winds, and growth. And you are part of it, carried along, not by effort tonight, but by the simple motion of rest. The slow rhythm of pistons fades, and now you drift into one of the most profound and oddly comforting ideas in all of science, the second law of thermodynamics. It is the law of entropy, the law that says, in simple words, the universe tends toward disorder. But don't let the word disorder sound harsh. Tonight, think of it more as a gentle whisper, a slow settling, a drifting toward balance. Picture an ice cube dropped into a glass of warm water. At first, the cube is sharp, cold, structured. The water around it is warm, lively, molecules rushing faster. Slowly, steadily, the cube melts, the water cools until both meet in the middle. Energy spreads out. Order softens. balance arrives. That spreading, that smoothing, is entropy at work. The second law says heat always flows from hot to cold, never the other way around. Your tea cools on the table. Your blanket warms as your body heat spreads into it. A fireplace glows, then fades, its heat leaking gently into the air. Left alone, warmth spreads. You drift now into a quiet kitchen. A spoon clinks into a cup of coffee, stirring cream into swirls. At first, the patterns are intricate white streaks twisting through black. But soon, they fade into one gentle brown. The order dissolves, the mixture equalizes, entropy increases. Scientists still wonder at the poetry hidden here. Entropy is not destruction, not chaos, but possibility spreading wider. Molecules gain more ways to arrange themselves, more freedom, more balance. It is the universe preferring variety over rigidity. And entropy doesn't just explain cooling tea or melting ice. It explains why time feels like it moves forward. Broken cups do not leap back together. Smoke does not drift back into logs. Cream does not unmix from coffee. The second law gives time its arrow. That sounds solemn, but it's also soothing, because entropy is not an enemy. It is a lullaby of inevitability. The universe itself drifts toward rest, toward evenness, toward stillness. You drift further now, past your room, past the earth, into the cosmos. Stars burn, galaxies spin, energy flows outward. Over unimaginable ages, the second law says, all differences will fade. Heat will spread until there is no hot, no cold, no imbalance left. The so-called heat death of the universe. But don't picture it as doom. Picture it as the quietest night imaginable. No struggle, no tension. Only balance, a final stillness, entropy complete. And yet, within this drift toward disorder, pockets of order bloom. Life itself thrives by borrowing energy, creating structure while the universe around it expands its entropy. The earth spins, winds blow, rivers flow, all temporary eddies in the great current of balance. Entropy allows these eddies. Without its tendency to spread energy, stars would not shine, winds would not blow, and life would not stir. So tonight, entropy is not a threat, but a comfort. It is the reason your blanket holds warmth. The reason your tea cools to the perfect sipping point. The reason time moves steadily forward, carrying you gently toward sleep. Let yourself rest in entropy's whisper. Everything tends toward balance. Everything spreads. Everything finds equilibrium. Your thoughts, too, can soften. From sharp and restless into wide and calm. From swirls and tangles into a quiet, even flow. This is the second law of thermodynamics, and it is not harsh. It is gentle. It is inevitable. It is peace. The melting ice and cooling tea fade into stillness, and now you drift into one of the quietest but most powerful gifts of the second law, the arrow of time. For though we often think of time as something mysterious, slipping endlessly forward, thermodynamics offers a simple whisper of explanation. Entropy increases. That is why time moves forward. Picture a child's toy block tower, carefully built, neat and orderly, each block stacked just so. A hand brushes it and the tower topples. Blocks scatter across the floor, bouncing, spinning, tumbling into disorder. That scene feels natural, expected. But the reverse, the blocks spontaneously leaping back into a tower, each finding its place. You will not see it. The second law does not allow it. Time, in this way, is a one-way street, from order to disorder, from concentrated to spread out, from the intricate swirls of cream in coffee to the smooth tan of a blended drink, from burning wood to fading ash and smoke. You drift now into a quiet kitchen again. A cup sits on a table. It slips, falls, shatters on the floor. The fragments scatter, entropy increases, time moves on. You could gather the pieces, glue them back, restore the form, but that is effort, energy borrowed from somewhere else. Left alone, the broken cup stays broken. This is why the arrow of time points forward, because disorder, once spread, does not unspread on its own. Scientists still wonder whether this link between entropy and time is the deepest truth or just part of the story. The equations of physics themselves, Newton's laws, Einstein's relativity, even quantum mechanics, often look the same whether time flows forward or backward. But entropy does not. It insists forward only. And you feel this arrow in your own life. Memories form in one direction. You remember yesterday, not tomorrow. A candle burns down, not up. Your body grows older, not younger. Time, like entropy, always moves toward spread, balance, diffusion. Yet within that forward flow, there is beauty. A breeze that cools the skin. A star that burns its fuel, shining for billions of years. A life unfolding, one moment after the next, each unique, each unrepeatable. Entropy gives time direction, but it also gives life meaning. Without the arrow of time, there would be no story. No beginning, no middle, no end, just stillness. You drift outward now, imagining the whole universe as a great clock. Its hands move not because gears turn, but because energy spreads. Galaxies drift apart, stars burn their fuel, warmth seeps slowly into the dark. All of it a measure of time's arrow. And perhaps, as you rest tonight, you can let that arrow feel less like pressure and more like rhythm. You do not need to chase it. You do not need to resist it. You can let yourself be carried forward, as gently as cream blending into coffee, as calmly as blocks settling to the floor. The arrow of time hums in one direction. Forward, always forward. And within that flow, you can drift into rest. The arrow of time drifts forward, always toward balance. And now you come to the quietest law of them all, the third law of thermodynamics. It speaks not of warmth spreading or energy transforming, but of a limit, an unreachable stillness, the idea of absolute zero. Imagine temperature as a measure of motion. The hotter something is, the more its atoms and molecules jostle, vibrate, collide. The colder, the slower they move. If you keep cooling, motion slows further and further until, at the very bottom, you reach the limit. Absolute zero, minus 273.15 degrees Celsius, minus 459.67 Fahrenheit. A number so low it feels less like temperature and more like silence. At that point, motion would stop completely. Molecules would cease their dancing, atoms would fall utterly still. No vibration, no jiggle, no warmth left at all. You drift now into an imagined laboratory deep in the night. Metal tubes and glass chambers hum faintly. Scientists have cooled gases to billionths of a degree above absolute zero, colder than outer space, colder than the void between galaxies. Inside their chambers, atoms line up in strange, delicate states, moving together as one, a Bose-Einstein condensate, a quantum stillness visible to the eye. Yet even here, the limit itself cannot be touched. The third law tells us why. Absolute zero is unreachable. No matter how clever the technique, no matter how carefully energy is siphoned away, there will always be a trace left, a final vibration, a whisper of motion that cannot be removed. Scientists still wonder at what this means for the universe. Does it mean motion, in some form, will always persist? That complete stillness is not permitted, perhaps. But for us, the message is simpler. The universe keeps a floor beneath its silence. You drift now through outer space, beyond stars and planets, into the deep night between galaxies. Out here, space itself is cold, just a few degrees above absolute zero. The afterglow of the Big Bang hums faintly, a whisper of warmth left over from creation. Even in the loneliest reaches, perfect stillness is denied, a reminder that the universe itself carries memory, a faint warmth that never fades. There is poetry in this. Absolute zero is less a number than an idea, a horizon. We can move closer and closer, but never arrive. And maybe that is as it should be. Motion, however small, is life. A little vibration, a little jostle, a little whisper of heat, enough to keep the cosmos from falling into silence. So rest now with this thought. The third law is not about despair. At a limit, we cannot reach. It is about reassurance that perfect stillness is not demanded of us. Even the universe allows a little trembling, a little imperfection, a little warmth left behind. You, too, are not meant to be perfectly still. Even as you rest, your heart beats, your lungs rise and fall, warmth drifts outward into the night. A gentle reminder that you are part of the same story. Never absolute zero, never silence, always a quiet hum of life. Absolute zero is an idea, but warmth is reality. The unreachable stillness of absolute zero drifts behind you. And now, you come back to something warmer, closer, and familiar. Thermodynamics is not only a subject of laws written in textbooks or experiments done in laboratories. It is the hum of your daily life, the rhythm beneath every ordinary moment. Take cooking. You place a pan on a stove, add a drizzle of oil. Hear the faint crackle as molecules gain energy and begin to move faster. Vegetables tossed in sizzle as their water content flashes into steam. The heat spreads, the meal transforms, energy flowing from flame to pan to food to you. The kitchen is an orchestra of thermodynamics. Conduction through the pan, convection in the bubbling liquid, radiation from the glowing coil. Or cooling. A glass of iced tea on a summer day, droplets of condensation forming on the outside. The ice melts slowly, pulling energy from the liquid, lowering its temperature. Warmth leaves the drink, slips into the air, equalizing. You taste refreshment, but what you are tasting is balance, energy flowing to even things out. You drift now into weather. A breeze brushes your cheek, cool against skin. That breeze is driven by differences in temperature. Warm air rising, cool air rushing in to take its place. Clouds form when warm, moist air cools and condenses, releasing heat into the sky. Every gust of wind, every drifting cloud, every drop of rain is thermodynamics in motion. Even your comfort at this very moment is thermodynamic. The blanket covering you traps the warmth your body releases, slowing the flow of energy into the room. Your bed beneath you presses gently upward, while the air around adjusts to your skin. Without thinking, you have wrapped yourself in a system of equilibrium, a little world of shared warmth and balance. Scientists still wonder how best to remind people that physics is not far away. It is here, always. Every sip, every breath, every breeze is a lesson. Think of a refrigerator humming quietly in a corner. It seems to create cold, but really it is moving heat, drawing warmth from inside, pushing it into the kitchen air. The price is always paid in energy, the hum of the motor, the warmth at the back coils. The first and second laws whisper together. Energy conserved, entropy increased. Or think of a breeze through an open window. The cooler night air slips in, spreading through the room, pushing out the day's heat. No one commands it. It is simply nature's rule. Warmth and coolness will share until they agree. And finally, think of your own body. You are a thermodynamic engine too. The food you ate earlier is transformed into energy for your muscles, warmth for your skin, fuel for your thoughts. Your body radiates heat constantly, so steady you barely notice it, a glowing ember wrapped in skin. Everyday thermodynamics is not exotic. It is tea cooling, ice melting, breezes blowing, ovens baking, blankets holding warmth. It is the poetry of balance written in daily routines. So rest now in this thought. You are surrounded by thermodynamics all the time. It is not distant. It is not hidden. It is simply the way the world moves energy around. And the same laws that guide stars and engines also guide your tea, your blanket, your breath. The universe does not change its rules for scale. The cosmos and the kitchen hum with the same song. The kitchen fades into quiet steam and clinking cups. And now you drift outward again, beyond mugs and breezes, into the greater engines that move the world itself. Because thermodynamics is not only about stoves and kettles. It is also the power behind oceans, winds, planets, and stars. Start with the earth beneath your feet. Inside, its molten core still glows from ancient heat, some left over from the planet's formation, some generated by the slow decay of radioactive elements. This inner warmth leaks outward, fueling volcanoes, geysers, and the slow drift of continents. The crust may feel solid, but beneath it, heat stirs and circulates, driving geology like an immense, hidden engine. Now look to the oceans. The sun warms the surface, while the deep remains cool and shadowed. Warm water rises, cool water sinks, and currents begin to flow, great conveyor belts moving energy across the globe. These currents carry warmth to faraway coasts, making some lands gentle and habitable while others freeze. The sea itself is a thermodynamic machine, redistributing energy so Earth can breathe. And then the atmosphere, always moving, always adjusting. Warm air rises at the equator. Cool air flows in from the poles. Winds swirl in great gyres. Storms form when warm ocean water feeds the sky with energy, spiraling into hurricanes. Each cloud is a small thermodynamic cycle. Condensation releasing heat, evaporation absorbing it, all together driving weather's endless dance. You drift higher now into space, where stars burn as the ultimate heat engines. In their cores, fusion transforms hydrogen into helium, releasing radiant energy. That energy takes thousands, even millions, of years to crawl outward, then streams into space as light and heat. The sunlight that warms your cheek on a morning walk began as nuclear fire deep within the sun's heart. The star is not just a light. It is a thermodynamic furnace, balancing gravity's inward pull with the outward pressure of energy. Scientists still wonder at how elegantly the second law explains these processes. Heat flows from hot to cold, and in doing so, it powers motion. The Earth's winds, the ocean's currents, the storm's fury, the stars' shine, all of them driven by temperature differences, all of them running on thermodynamic gradients. Even life itself is an engine of sorts. Plants capture sunlight, lock it into sugars, and pass it along as energy to animals. Every breath you take is part of that cycle, oxygen fueling your cells to release energy from food, warming your body, keeping you alive. The engines of the world, then, are not made of pistons and steel, but of oceans, skies, stars, and living cells. All run on the same principles. Energy flows, warmth spreads, entropy increases. You drift now between these great engines, watching them move gently. Oceans circulating like slow breaths, clouds blooming and fading, stars shining steadily, their light reaching across gulfs of space. None of them hurry. None of them pause. They are the universe's way of balancing, transforming, and sharing energy. And perhaps tonight, as you rest, you can feel yourself as part of this same system. Your body radiates warmth like a tiny star. Your breath stirs the air like a small wind. You are not separate from thermodynamics. You are one of its engines, humming quietly in the dark. So let yourself rest in this thought. The world is full of engines, great and small, each running on the same simple rules. From the boiling pot in your kitchen to the blazing sun in the sky, everything moves on the flow of heat. And just as surely, tonight you move on it too. The oceans and winds, the fires of stars, they all hum with energy in motion. And yet, as you drift further outward, you begin to see the deeper pattern, the larger tide that carries not only the earth, not only the sun, but the universe itself. It is the tide of entropy. Entropy, that gentle whisper of the second law, does not stop at teacups or campfires. It stretches across galaxies. Every time energy flows, every time heat spreads, entropy grows a little higher. Bit by bit, moment by moment, the universe drifts toward balance. Picture the stars. In their cores, fusion burns brightly, energy flowing outward, light spilling into space. But stars cannot burn forever. Their fuel runs down, their heat spreads outward. The night sky is filled with starlight, but that light, once scattered, does not return. Each ray is entropy in action, energy dispersing, never to be recollected. Galaxies, too, drift apart, carried by cosmic expansion. The warmth of the early universe spreads thinner and thinner. A faint afterglow stretched across the heavens. That glow is the cosmic microwave background, the soft whisper left from the Big Bang. Once, it was searing light. Now, billions of years later, it is just a few degrees above absolute zero, a reminder of entropy at work. Scientists still wonder what the far future will look like. The prevailing thought is something called heat death. Not fire, not explosion, but silence. All differences in temperature smoothed away, every star burned out, every gradient flattened. No more hot or cold, no more energy to flow, just a uniform stillness. It sounds bleak at first, but let yourself hear it differently. Imagine the gentlest night, the universe at perfect equilibrium, nothing strained, nothing struggling, only balance. A final exhale after an eternity of breath. Entropy complete, not as destruction, but as rest. And in the meantime, entropy gives us everything we know. Without energy flowing downhill, stars would not shine. Rivers would not run. Life would not stir. Entropy makes things possible by allowing gradients, differences of hot and cold, to exist for a while before they fade. You drift now through a galaxy, spiral arms glowing faintly. Each star a brief island of low entropy, burning brightly while it can. Between them, gas clouds swirl, black holes feed, light travels outward. All of it is temporary order, small eddies in the river of entropy. And you, too, are part of this. Your body runs on differences, food carrying energy, your cells using it, warmth flowing outward into the air. You are a temporary pocket of low entropy, alive for a time, then giving your energy back to the wider universe. There is comfort in this perspective. Entropy is not only the end of things, it is the context of all things. It is the reason stars shine, the reason galaxies glow, the reason life flickers here on Earth. So rest with this thought. You are part of entropy's grand tide. A small, warm eddy in a vast, cooling cosmos. The energy in you now was once sunlight, once starlight, once part of the universe's great unfolding. And someday it will spread outward again, carried into the balance. Nothing is lost, nothing wasted. Everything drifts gently, softly, into the night. The vision of distant galaxies drifts behind you, and now you turn your attention back to something subtler, the strange balance between order and chaos. Thermodynamics whispers that entropy increases, that disorder spreads. And yet, as you look around, you see order everywhere. Stars shining, rivers flowing, life thinking and breathing. How can order persist in a universe that leans toward disorder? The answer is balance. Entropy always rises overall, but in small pockets, Order can bloom as long as, in doing so, entropy increases elsewhere. The universe allows these oases of structure, like flowers opening briefly in a vast meadow of change. Picture a seed sprouting into a tree. From soil and sunlight, water and air, the seed draws energy and grows into branches and leaves, an organized pattern far more intricate than the seed alone. But the process is not free. The tree radiates heat, exhales gases, spreads entropy outward even as it builds order within. Or picture the Earth itself. Our planet glows with life and structure, but only because the sun pours energy in and the Earth radiates it back into space at lower quality, more spread out. In this trade, entropy rises, yet order blossoms here for a time. You drift into a kitchen once again, where dough rises in a warm bowl. Yeast feeds, bubbles form, the dough swells into airy structure. Inside the bowl is new order, pockets of gas, gluten strands weaving a network. But the kitchen air is warmer, entropy has increased overall. A balance has been kept. Scientists still wonder if life itself is best understood as a thermodynamic process. A local decrease in entropy paid for by a greater increase in the surroundings. Some call life a dissipative structure, something that thrives precisely by using the flow of energy from hot to cold. Chaos makes order possible. Without entropy, there would be no drive for change, no currents to feed complexity. The universe is not a machine that resists disorder, but a dance that uses it. You drift now above the Earth at night. Cities glow, rivers shine faintly, lightning flashes in clouds. Patterns bloom and fade, each one feeding on energy, each one temporary, each one an oasis of order. And yet, taken together, the flow increases entropy overall. And perhaps this balance carries a quiet comfort. You do not need to fear disorder, nor cling desperately to order. Both are part of the same law. Both are necessary, intertwined. Your own body is a balance of order and chaos. Cells maintain delicate structure, but they do so by radiating heat, by releasing entropy. Your thoughts form patterns, but only because neurons fire and chemical gradients shift, spreading energy outward. You are a brief pocket of order in a wider sea, and that is exactly as it should be. So rest in this truth. Order and chaos are not enemies, they are partners. Life blooms in the tension between them, using the spread of entropy to create temporary patterns, fleeting but beautiful. The fire burns down, the ashes scatter, but for a while there is warmth, light, shape, meaning. And tonight, you are part of that balance, structured enough to think, soft enough to rest, carried forward by entropy's gentle hand. The balance of order and chaos fades into the background, And now you drift back down to something closer, something simple and ancient. The warmth of people together. Because thermodynamics is not only in stars and galaxies, it is in every fire ever lit, every shared blanket, every breath of warmth passed from one body to another. Picture an ancient camp thousands of years ago. A small fire crackles at the center, its glow painting faces in amber light. People gather close, shoulders touching, sharing food, telling stories, keeping watch against the night. The flames radiate heat outward, but so do the people themselves. Each body a small engine, burning food into warmth, breathing heat into the air. Together they make the night bearable. Move forward through history, and the hearth becomes the heart of every home. Families sit near it in winter, hands stretched toward the flames, meals cooking slowly in the coals. The fire is not only survival, it is comfort. It draws people inward, creates a center, a place where energy and stories circulate. You drift now into a stone-built bathhouse in ancient Rome. Steam rises, condensation clings to walls, the air thick with warmth. People relax together, talking softly, bodies soaking in the shared heat of water warmed by furnaces below. Even here, thermodynamics is at work, conduction through the stone, convection in the pools, radiation from the braziers. But to the bathers, it is simply peace. And in modern times, the story continues. Central heating hums quietly in homes. Hot water radiators tick and sigh, distributing energy throughout rooms. Families still gather in kitchens, where ovens glow and stoves release gentle waves of warmth. Couples curl together beneath blankets, exchanging heat, skin to skin. Scientists still measure human warmth as numbers. The average person radiates about 100 watts of heat at rest, like a soft light bulb glowing invisibly. But to those nearby, it is not a calculation. It is the comfort of leaning close, of a hand resting in another's, of bodies adjusting together until balance is found. Human warmth is thermodynamics lived personally. Two people lying side by side begin with different temperatures, different rhythms of heat. Slowly, imperceptibly, they equalize. The zeroth law written in bodies. And beyond physical warmth, there is the warmth of presence, of words shared, of laughter, of silence held together. Not measurable in joules or calories, but real nonetheless. Perhaps this, too, is a form of thermodynamics, energy flowing, spreading, equalizing between people, until balance and comfort emerge. You drift now into a winter night. Snow outside glows faintly in moonlight, the air sharp and cold. Inside, a fire burns. A group sits close, shoulders touching, voices low. Their warmth fills the space, not only from flame but from each other. The cold may press against the walls, but inside, balance has already been reached. So rest in this thought. You are part of this long story of human warmth. From ancient campfires to modern quilts, from shared hearths to quiet hands, the laws of thermodynamics are woven into our lives not as abstractions, but as comfort. And tonight, as you lie beneath your blanket, your warmth radiates gently, part of the same pattern. Not lost, not wasted, but shared with the world around you as it has been for all of human history. The fire glows, the blanket holds, the body warms, and you are safe in the thermal night. The memory of shared fires lingers softly. And now you drift into something less technical, more reflective. The way heat has always carried not just comfort, but meaning. Because for as long as humans have known warmth, they have written poetry about it, woven it into metaphors, carried it in symbols. Thermodynamics is physics, yes, but it is also feeling. Think of fire as the oldest image of passion. Ancient myths spoke of flames stolen from gods, flames that gave life, wisdom, and danger in equal measure. To be fired up is to be filled with energy. To burn with love or burn with anger is to glow with emotion too hot to keep inside. Even today, we use heat as a language for our inner lives. Heat is also memory. A kitchen that smells faintly of bread, still warm from the oven. The steam rising as you tear it open. A blanket passed down, heavy with fabric and the faint scent of those who used it before. A summer's day that lingers on your skin hours after the sun has set. Warmth, in these moments, is more than temperature. It is the sense of belonging, of being held. You drift now into imagery. The sun rising over a cold meadow, spilling gold across the grass. The glow of lanterns in winter windows. The hush of a sauna, steam curling into rafters. Each one is thermodynamics, yes, but each is also poetry, energy as comfort, heat as metaphor, warmth as story. Scientists still wonder at why humans attach so much meaning to heat. Perhaps because warmth is survival. Perhaps because it has always been scarce, precious in cold nights. Perhaps because we feel it so personally, on skin, in breath, in the very energy that keeps hearts beating. But you need not wonder. You can simply feel it. Heat is change. A frozen pond melts, becomes water, later rises into mist. A log burns, becomes flame, smoke, ash, warmth in the air. Heat is the language of transformation, the bridge between what was and what will be. And there is a gentleness here. Change can be frightening, but seen through the poetry of heat, it is simply the way of things. Cold softens into warmth. Warmth diffuses into coolness. Everything moves, everything balances, everything transforms. You drift now through time. Ancient poets wrote of fire as divine. Medieval philosophers studied its mysteries. Modern physicists defined its laws. But through all of it, the meaning remained: warmth is life. To sit by firelight is to feel safe. To share warmth is to share care. To rest in balance is to belong. So let this poetry ease you now. The heat in your blanket is not only thermodynamics. It is comfort, connection, transformation. It is the world whispering that you are held, that you are part of the same warmth that has glowed in stars, in hearths, in hearts, across all of time. The poetry of heat is simple. Warmth is comfort. Warmth is change. Warmth is life. And tonight, that poetry is yours. The poetry of heat softens, and now you drift into the last chapter of this journey, the quietest part, where the science and the metaphors meet and both dissolve into rest. Thermodynamics has carried us from hearths to stars, from steaming cups to galaxies cooling into silence. And through it all, one theme has remained: balance. Heat flows until temperatures equalize. Energy transforms but is never lost. Entropy spreads and time moves gently forward. Picture yourself lying beneath the night sky. The air is cool, your blanket warm, your breath steady. Above you, stars burn, pouring their energy outward into space. Around you, the earth radiates warmth into the night air. Within you, your body releases its heat, molecule by molecule, into the world. All of it is thermodynamics. All of it is natural. All of it is comfort. Entropy increases, yes, but not as destruction, as rest. A hot drink cooling, a candle flickering out, a day's warmth fading into evening. These are not catastrophes. They are lulls, the universe exhaling. Scientists still wonder about the far future of this entropy-driven cosmos. The so-called heat death, when everything will be evenly spread. No hot or cold left. But tonight, let's imagine it not as an end, but as the ultimate stillness. The quietest night of all. Nothing wasted, nothing strained, only balance everywhere. And between now and that distant horizon, there are countless pockets of warmth, stars, fires, hearts, blankets. Local comforts against the grand cooling, each one a small defiance, a brief oasis of energy before balance is restored. You drift now into one last image, a hearth glowing faintly, embers sinking into ash. The air still warm, the room calm, the night patient. You feel your body's own heat echoing the embers, steady, safe, shared with the space around you. Slowly, steadily, your warmth equalizes with the blanket, the air, the room. Balance already on its way. This is the lullaby of thermodynamics. Heat flows, energy balances, entropy whispers. The arrow of time carries you forward, gently into sleep. So close your eyes now. Breathe deeply. Feel the comfort of warmth at rest. The thermal night holds you softly, steadily. You are part of the same story as tea cooling, stars burning, the universe sighing toward balance. Rest in that thought. Rest in that law. Rest in the thermal night. And now the journey grows quieter still. We have wandered through warmth and balance, through engines and entropy, through stars and blankets. The laws of thermodynamics have unfolded not as commands, but as lullabies, gentle reminders that energy moves, that warmth spreads, that everything seeks equilibrium. You don't need to hold the details anymore. You don't need to remember which law was first, or why entropy rises, or how stars burn. The story can dissolve now, like steam fading into cool air. Take a slow, deep breath. Let it out softly. Notice the warmth of your body, steady and constant. Notice the blanket or air around you, holding that warmth close. You are already part of the laws we've spoken of, a small, quiet system seeking balance. And balance will come. It always does. Let your muscles soften, sinking into the surface that supports you. Let your thoughts scatter, like cream blending into coffee, until they lose their edges and become smooth. Let your breath slow, like the fading embers of a fire. The night is here to hold you. The universe is patient. Time drifts forward, gently carrying you with it. You are safe. You are warm. You are at rest. The story has ended, but its rhythm remains, the soft, steady hum of energy seeking balance, the quiet whisper of entropy carrying everything toward peace. So close your eyes a little heavier. Let go of thought. Let go of effort. Let the thermal night carry you into stillness. All is calm. All is balance. All is sleep.